Cardiovascular Systems is a medical device company located in the U.S., and we design, develop, manufacture, and market solutions for treating peripheral arterial disease. Our device goes in and it sands away the plaque. So when the device is activated, it begins to spin up against the hardened plaque, taking that away. And that restores the flexibility of the blood vessel so that you can go in and treat it with any additional therapy that you might want to use to finalize the treatment for the patient and provide the best outcome.
CSI is a company where we pride ourselves on being on the cutting edge and being ahead of the industry, ahead of our competitors on what we're doing, even with the main device with our core technology, but also outside of that and anything we can do to better assist our doctors, better assist our patients. In order to communicate with our suppliers, communicate with our industrial design firm, communicate with our ergonomics people, who were all also using SolidWorks, that we needed to get up to speed and get into SolidWorks and really start using it in a meaningful way in our production and our design environment. We got to the point where we needed to get more into a multi-user environment, and that led us to a PDM tool. Our management kind of came to me and was like, okay, here's what we think we need so we can rev control things, so we can not have colliding revisions and maintain sub-assembly structures, all the great things that SolidWorks gives you when you're building designs in it. And it was one of those things that once we got it up and running, it was like, how did we ever live without this? We were spending a lot of money on prototypes, spending a lot of money on things that just didn't work, so started looking at SolidWorks simulation as a solution for our FEA, doing some analysis. Basic stress analysis for static parts, all the way up to dynamic simulations in assemblies. The purchasing group were looking for some cost savings ideas, changing the stem of the part from a steel stem, overmolded steel stem on a plastic knob, to a completely 100% plastic part. Within a few hours I was able to run a simulation on that, make a pretty definitive decision very quickly that within the load environment that we were experiencing with that particular part, that an all-plastic part just wouldn't cut it. With that, it was very cool that the SolidWorks simulation tool pretty much paid for itself almost instantly within the first, I'd say, couple of weeks, month or so of having it.
In my usage of SolidWorks thus far, I've yet to find something that it can't do that I need it to do, and it's more so me catching up to the software, basically broadening my understanding of how it works and how best to use the tool. The innovation part is key, both to continue to advance therapy and to stay ahead of our competition, which is fierce. So we use SolidWorks to basically give us a leg up on making sure as we innovate, as we create, it's being captured and documented in a form that we can use it quickly and revise it quickly, so that we can turn it into something that, again, that benefits the patient directly.
If you don't use SolidWorks, I don't understand how you would be an effective engineer, be an effective company in basic things like communicating with your suppliers and communicating within the engineering team itself. It really allows us to make changes on the fly, try things out, figure out basic things like clearances and tolerance stack-ups that SolidWorks all just does right there visually for you. And so it's really, really an indispensable tool. And, you know, I really couldn't imagine life without it, to be honest with you.